Welcome to the Cosmic Tea Party, Scientifika. Today I'm here with Miriam.
Hello.
Lauren.
Hey.
And Sam.
Hello.
And this is Chris, and I'll be co-hosting with these lovely folks today and throughout our series. Today we're talking a little bit about terraforming. But before we get into that, I thought we might just give a bit of a rundown of what the hell this show is all about. So this is a spin-off project from the Cosmic Tea Party podcast, which is a blog and podcast we did up to a decade ago now. But this time we're in a different town. We're in Stockholm in Sweden, although I'm sure that we'll hear from our old hosts sooner or later. That's Anthony, Anita, and Nadine. If you can think about it, if science podcasts were like cheesy music talent shows, then the original Cosmic Tea Party would be like Australian Idol, whereas Scientifika would be like Eurovision. It's a bit more culturally diverse. But they're both trashy and both have too many Australians. So the format's a little bit different as well, where we just focus on one single topic in science and focus on topics that have a lot of impact on pop culture. And we're going to tackle different aspects of that topic and really do a deep dive. As we go forward, we're going to be experimenting with different formats, and the content will be pretty diverse, as you'll find out. So today's topic is terraforming, as I mentioned. Now, at this point, maybe this is a good place to squeeze in some David Bowie, maybe Life on Mars. Does anyone want to sing us a bar of that? Really not? Okay. Well, I guess it's up to me. I was thinking it'd be a good remix, Life on Mars and Changes, changes, because it's all about changing. All right, fine. Let's just move right on. So what is terraforming? That's the first question that we should tackle. There's different aspects of this, but it seems like the consensus is modifying the atmosphere or the hydrosphere or the topography or ecology to make it more similar to Earth, so that things that live on Earth can make a home on these different places. So we're talking mostly moons and planets. Other people talk about some pretty crazy ideas in asteroids or other heavenly bodies. Now, one of the things to consider is what are the essentials for life, or life on Earth that we know. So this is from NASA's Astrobiology Roadmap. What they define as essential for an ecosystem are extended regions of liquid water, conditions that are favorable for complex organic molecules, so organic molecules being ones that incorporate carbon, and some sort of energy source. It doesn't have to be the sun, although that seems to be the one that's most common on Earth. But you could also have chemical energy sources, so hydrothermal vents in the middle of the oceans, quite prolific sources of energy for a whole bunch of weird organisms on our planet. And so it seems like the ultimate goal for, if we're going to terraform anything, is to make it habitable for humans. Now that's actually a pretty extreme difference between just any life on Earth and humans, because humans tend to want some pretty specific things. Like, I know, depending on who you talk to, which humans you happen to run into, some can't live unless they have enough leg room on the airplane, or they can't live without their iPhone, or they can't live without a chai latte with skinny soy decaf. So it's ideal also if you could have it self-sufficient, instead of just having a one-off habitation, and then all of a sudden things get really bad after 10, 15 years. You want an environment that's going to be consistently good for a long time, so that we can have multiple generations of organisms. 3 books are really relevant to this topic. It's called The Mars Trilogy by Kim Stanley Robinson. I don't know if you guys have read that, but anyone who wants to check out a really cool thought experiment about how terraforming could go, I recommend checking this out. They're pretty amazing. The sort of detail they go into is pretty impressive. And one really important thing that came out in 2016 was this really cool board game called Terraforming Mars, and it's a pretty interesting approach. We'll might mention some of the things they talk about in the game later on as they come up. And the timescales they talk about is pretty realistic. They're talking multiple generations of colonizers and terraformers to make Mars habitable for life on Earth. It's a pretty long-term perspective on that.
Yeah, I think it's quite good, and the way that they kind of have these positive feedback mechanisms, like you get over a certain level of oxygen and then things start accelerating, and then same
exactly.
with the plant life, and sort of as you get past a certain threshold, things start getting easier and easier in terms of turning it into a kind of Earth-like planet, which is sort of what probably would happen. I mean, the initial barrier to get it over a certain temperature to basically get liquid water would be one of the major factors.
Yeah, that's true. Yeah. And then, like you said, those positive feedbacks are quite important. If you thicken the atmosphere, then that actually has a whole bunch of positive effects for other things. Not just a thick enough atmosphere that we can breathe and all that stuff.
Yeah.
But it also promotes greenhouse gas effects and but yeah, we'll go into that. There's also a pretty important book written by a guy named Fogg in 1995, and this is basically a textbook for terraforming. It's really quite impressive. It's called Terraforming: Engineering Planetary Environments.
Right.
So that's a sort of a go-to book for that.
Is that kind of like a scientific book, as in trying to find real answers to these questions?
One thing I found remarkable about all this stuff is that how the science, this is a science fiction topic, and it's remarkable how little science there is compared to how much fiction there is. Because we haven't really done any good experimentation on this. We haven't had a good chance to dabble with the climate or the hydrosphere of another planet.
It's
so speculative.
This whole topic is really, as you say, sort of hypothetical. Well, we don't have any real experience of actually doing this.
No. Yeah,
we're probably on a large scale anyway. Yeah.
So with that big caveat in mind, you have to take our musings and our bollocks with a bit of a grain of salt, because a lot of it may end up being a bit speculative and a bit bullshit mixed in. So let's not set our sights on traveling to Mars straight away and taking this podcast as the source for your ideas on terraforming. Okay, Sam, I think you were going to tell us a bit about what options we have if we were going to blast off from the Earth tomorrow. Where the hell would we point our spaceship if we wanted to go terraform?
Well, we've sort of mentioned about Mars, and this is sort of the common topic in terms of terraforming. We always talk about Mars, but what are the other options, and sort of why do we think that Mars is the best option? So some kind of other candidates other than Mars would be, the most obvious one would be the Moon, because that's our closest neighbour. So that would be a kind of good candidate in terms of we've already been there. It's pretty close. We can get there within 3 days with a Saturn V rocket, which we no longer have the technology to potentially produce again, which is something different. But
hey, my folks are actually in Florida right now, and they went and visited the Saturn V. They went and saw this monster. It's unbelievable.
Yeah, I saw one in Houston.
Have you seen it?
It's insane. It's just like a skyscraper on its side, and
yeah, it really is. And usually I think they house it in this massive warehouse, and this.
Yeah.
How do they bring these things down? Are they staying in space?
So these are the ones that they haven't used. The Saturn V's were sort of a one-off, one-use only rocket. So they would blast off, and then as they go up into space, they would jettison certain bits. They would just discard. Then they would be deorbited and thrown back into into Earth.
But
most of the stuff would just fall back down as it's
to the Earth.
Yeah.
Isn't it dangerous? Yeah.
Well,
it's pretty dangerous.
It's not dangerous if you're not standing under it. So I think they generally aimed to do it so that they come down over the ocean.
Yeah.
And so a couple of dolphins maybe got a bit of a rude awakening.
That's rude.
Oh. If it makes you feel any better, we're not doing many rocket blasting anymore, which is a real.
I think that's as well why they take off in Florida. So as they're going up the Earth, when the Earth is spinning, that when it falls back down, the different pieces of the rocket, they'll fall into the Atlantic. And it's also because they want to get kind of close to the equator, because they'll get a lot more, I think, speed.
Yeah, more of that centripetal force of the rotation.
It's a lot easier to actually get into orbit.
Like the Earth is slingshotting them out into space.
Yeah.
So why the hell not the Moon? Why the hell?
So the Moon is a potential option because it's so close, and that kind of has a lot of good things about it in terms of its distance.
If some bad shit went down, we can get there pretty quick.
I mean, like a rescue mission is a feasible thing if the shit hits the fan big time. You can go and potentially pick people up. And also we can send things up there, send resources for the initial stages of terraforming or setting up colonies, which would kind of happen before properly terraforming. This would be a massive advantage. But there's also economic reasons to go to the Moon. And one of the big things that people talk about is the helium-3 that's there, and this is a potential fuel for nuclear fusion.
Really?
If this
Huge.
technology's able to take off.
Have you seen that movie Moon?
Yeah, I was just about to.
Such a good show.
Yeah,
Such a
and
good movie.
that's sort of about that. Yeah, that's like about this solitary stint of mining for helium-3
Yeah, really
on
cool.
the far side of the moon, and there's a lot of cloning type topics in. But this is like the moon is one of the best candidates for building a base on, basically because of its distance away from Earth. But this isn't really terraforming. This is not what we're talking about. We're talking about changing the entire planet into an Earth-like planet
Or moon,
that we
yeah.
can survive on. But then, some other candidates like Venus. This is most of the time Venus is the closest planet to the Earth. So at different points in the
You mean
Earth's-
closest by distance?
Yeah, closest in terms of distance. So sometimes Mars is the closest, sometimes Mercury is actually the closest,
What?
depending on the So if like Venus and Mars are both the other
of course.
side of the sun,
Okay, yeah.
and then different times of the year, the different planets are
Uh-huh.
situated differently. It's also like you can see it a lot of time.
How warm is it there?
Ooh, 740 Kelvin.
Yeah, which
Right.
is about
So
462 Celsius.
yeah, it's cooking. It's pretty toasty.
So it's hot.
Like, it's hot enough to melt lead, apparently.
So the kind
Pretty
of good
cool.
things about Venus is the size of the planet. It's pretty similar to Earth in terms of its size. So all
that's
these
true.
problems to do with gravity, they're not really an issue on Venus because
Mm.
it's the same size as Earth.
Well, I like it hot, but that seems a bit too hot.
So it's the hottest planet in the solar system.
And the other really important thing about Venus is it's quite limiting is that, well, two things. One is that it's super high pressure there. Like if you're standing on the surface of Venus, it's like 90 times the Earth atmosphere. So it's kind of like you're trying to live under a kilometer of ocean, which some organisms can, but humans might have a hard time doing so.
It's the pressure, the temperature. It's too extreme.
Feels like a bad angle there.
A lot of pressure.
Wait, right now?
Okay,
You
sorry,
don't
that
have
was my first word of the whole podcast, but yeah.
I think it's just
Sorry.
because Lorraine has just woken up from
Heavy night.
90 atmospheres of pressure. Is that how it feels like? Yeah, and the other thing that would kill you pretty quickly, apart from everything else, is the sulfuric
Sulfuric
acid.
acid,
Yeah,
yeah.
in the atmosphere. It's horrible, man. That's pretty corrosive shit.
But the reasons for this are, due to the kind of runaway greenhouse effect that Venus probably underwent in its early history. So this is basically too much CO2 in the atmosphere. Most of the atmosphere of Venus is CO2, so it's over 95% of the atmosphere. And it's, a very thick atmosphere. Basically, what not to do with a planet
Yeah.
and where not to go.
In case we could get rid of this atmosphere, would it be cooler?
Yeah, absolutely.
Yeah.
So there was one pretty wild idea by Carl Sagan, the astronomer. Got a bit of a man crush on that guy, I must say. He's pretty amazing. Well, he died, unfortunately. In 1961, he came up with an idea to try and terraform Venus using algae. It would digest the CO2 in the atmosphere, churn out a whole bunch of oxygen, and make it just a little bit more habitable by life on Earth. But you still have the same problem with huge amount of atmospheric pressure, sulfuric acid in the atmosphere. So the temperature would go down because oxygen is not a greenhouse gas like carbon dioxide is, but it would still be pretty extreme. So that's just one, tiny parameter of a much larger problem. So, and we know of a whole bunch of bacteria that can survive in high pressure, and some bacteria that deal with extreme temperatures as well.
Yeah.
So it's not too bad an idea.
Yeah.
In 1961, he did say algae, but more recently people have said cyanobacteria. That's why I mentioned bacteria.
Right, yeah.
Make sure I get that right. Algae are not bacteria. Thank you very much.
One of the kind of subsequent thoughts about this is that it actually wouldn't be possible, but the reason is because of the sulfuric acid in the atmosphere, so this would probably kill everything anyway.
Yeah, it's pretty grim.
But yeah, this is the sort of type of thinking that you want to try and terraform these planets. But also the days on Venus are way too long.
Oh,
So
really?
the day is about 244 Earth days, which is actually longer than the year. So this is 225 days.
Oh, man.
So it's a long day.
Bloody hell. Hope you get paid overtime. That's pretty ambitious, I must say.
To do the Venus instead of the Mars.
Yeah.
Are you sure? I'm not sure.
To terraform Venus?
Yeah, maybe that's easier than to change the conditions on Mars.
Well,
Yeah, it's the total opposite
one of
thing
them.
Yeah.
that you're aiming for.
Yeah.
You're trying to cool it.
All right, well, maybe we'll come back to that question.
Well,
That's a
we
good one.
can't.
That's a good one.
Actually, the reason why we need to leave Earth like urgently is because like it's super warm and we still don't even manage to just decrease by half a degree.
Yeah, can you imagine?
So I mean, I'm just saying, it seems like it might take a little while before we figure things out on Venus. And if so, then why not just trying on Earth first? I don't know.
Yeah, we can't even deal with 2-degree increase, let alone 200 and something degree.
Yeah.
Yeah, that's pretty. Yeah, that's a good point.
Maybe if we start getting rid of Donald Trump, it could make things a bit easier. But you know.
That's on our other podcast, the Cosmic Political Party. Any other potential targets, you think?
Yeah, so these are kind of the close by planets. Well, Venus and the Moon.
Mercury's not an
Um,
option. I guess it's just too hot, too dry.
Yeah, too hot,
Not
not
much
enough
going on.
atmosphere.
Yeah.
But then there's also the kind of large moons of the gas giants, and an interesting candidate would be Titan, which is the largest moon of Saturn. And I think this is larger than Mercury, so it's a pretty big planetary body.
Oh, the night sky must look awesome next to Saturn. Wow.
That'd be amazing.
But I think it would actually suck because you can't really see through the atmosphere because it's so dense.
Shit.
So it'd just be like an orange haze.
Once you've terraformed it enough and you can see through the atmosphere, then I think the tourist dollar you could get would be enough to pay for all the colony there, because it would look amazing, wouldn't it? If you could stand on the surface and just look at
And
the
just
rings.
have a look at Saturn, yeah. But this is like one of the only moons to have, well, I think the only moon to have a dense, thick atmosphere. Yeah, and this would be probably quite difficult to actually see through. And it's been difficult to see through. That's been a problem with actually looking at the moon and trying to work out what's going on under the surface, because we can't actually see through the atmosphere that well. But in 2005, the Huygens mission went to Saturn, and the Huygens probe actually was part of the Cassini probe and kind of detached from it and went through the atmosphere of Titan, and on its way down it took photos kind of in 360 degrees as it was descending through the atmosphere. And yeah, I encourage you to kind
That's
of
cool.
go and have a look at these photos. They're really incredible, and you can see these possible liquid hydrocarbon lakes and rivers, and so
Well,
it's got
like-
some kind of hydrological but not based on water cycle.
So it's like methane, or
Yeah, so yeah, hydrocarbons that we have here on Earth, but because it's so cold there, they're in a liquid state there. But yeah, Cassini's kind of confirmed that there are these permanent liquid hydrocarbon lakes, particularly at the polar regions of Titan. Pretty incredible pictures when you see them. And there are also these other bodies like the ice worlds of Europa, which is a moon of Jupiter, and Enceladus, which is a small moon of Saturn. And these could potentially harbour life. They're kind of ice bodies with which possibly have liquid water below the surface. But in terms of harbouring humans, in terms of actually being able to survive there and terraform, these are not really good candidates. So yeah, this takes us to Mars, which is the best kind of the most realistic candidate for actually terraforming.
I'm gonna squeeze in a quick caveat there. It's the most likely candidate in our solar system, but I mean, it's a pretty exciting time to be alive right now, because we're finding a whole bunch of planets outside of our solar system which might actually be more habitable than anything else apart from Earth in our own solar system, which is super cool. So I think in our discussion today, we're just focusing on the stuff that's within our own solar system, because we don't know enough about these other potential planets yet. Hopefully we revisit this topic in a year or 2 or 10, and we can actually talk about a whole bunch of these really cool potential planets around other suns.
Yeah,
Of course, the practical problems of getting there are going to be huge for those other ones.
yeah.
So yeah, we're on to Mars now, which I think, like you said, is the most likely candidate within our own reach, and something we've actually reached with our own probes, which is a pretty good start.
Yeah, and it's like you said, we can actually land something on the surface, so without it melting like it does on Venus.
Bonus.
And it's kind of realistic to send humans there, although we haven't yet, obviously. It would take about 240 days to get there, which is going to be an extreme journey, but it's potentially doable without these crazy technologies, like, as you said, you mentioned exoplanets around other stars. These are going to require totally different methods of transport of getting there, maybe kind of being freeze-dried on the way there or something. But with Mars, this is kind of a potentially realistic thing to actually get humans there. Yeah, there's kind of these two big factors that make Mars not so good, and that's the fact that it's extremely cold, and it's quite far away from the sun relative to the Earth, and there's a lot of variation between the temperature on Mars, but the kind of common value for the average temperature is about minus 55 degrees Celsius. So
chilly.
This is pretty chilly.
That sounds a bit like Sweden, really.
Yeah, it's pretty similar. But on a good day in the kind of equatorial region, it can get up to potentially plus 20 degrees Celsius.
Oh wow.
Wow, that's
Yeah,
pretty
so it's
good.
pretty nice and toasty.
Wow.
And then the second kind of big problem is the fact that Mars is pretty small. So it has about 38% of the gravity compared to Earth.
And that's a problem, actually.
Yeah,
Well,
that's
that's actually one of the most important problems of the lot.
yeah, that
So
has a
freaking hard
lot
to change.
of different effects that kind of make it very problematic.
Exactly.
So it's bigger than the moon. So it does have a thin atmosphere, and this is really important for being able to survive on an actual planet.
Because they're related though, aren't they? The atmosphere and the size, because it needs to be big enough to retain the atmosphere under gravity.
Yeah. So this is one of the main kind of hurdles that is possibly impossible to get over. So because it's a lot smaller than the Earth, the internal structure of Mars actually cooled a lot faster than Earth in its early history, and that means that the planet doesn't actually have plate tectonics, which are really important because they generate a magnetic field on Earth, and this is the thing that basically stops solar winds eroding the atmosphere. So as the solar winds are coming in, the atmosphere on Mars just gets gradually eroded away, and resultantly now we've got a very thin atmosphere on Mars because of this.
So it's the stripping away of the atmosphere by the solar wind. And it's not so much that the atmosphere gets lost to space because there's just not enough gravity. It's actually because the ionizing radiation from the sun is pulling it away from the planet. Is that right?
Yeah, so the fact that it would be big would be good for holding in the atmosphere, but also the lack of magnetic field because it's small also has that compounding factor as well. But interestingly, the actual landmass on Mars is, in terms of its habitable area for humans, so because we are land-based animals, it's about the same as Earth. So because Earth is covered by 70% oceans,
Okay, cool.
the actual land is fairly similar to that of Earth.
So if everyone on Earth had to pick up and leave and go to Mars, we could pretty much just re-establish everything. Plan B in case the Earth goes to shit. We can just pick up and leave. Easier said than done.
But yeah, in a lot of ways, it is the most Earth-like planet in the solar system, which obviously makes it the one to go to, and it hosts a lot of these actual natural resources that are there for the taking, essentially, because one of the key things about terraforming is that we don't want to be sending stuff there constantly. So we don't want to be sending packages of food, water. Water's just too heavy to send export to Mars, and it does have these big amounts of water locked up in the polar ice. So
and the carbon dioxide, which is really important for retaining heat. That's a total waste of energy. If we have to drag everything we need from this planet, it's just completely impractical.
Yeah, it's not a feasible thing. We want to be generating the stuff that we need in situ.
So as you just said, Mars likes plate tectonics and volcanism, and that's a problem not only because I think most of us would have to find an odd job, but also
the geologist would be out of work. Yeah, that's true.
Yeah, but also of course plate tectonics plays an important role when we talk about CO2 recycling, and of course it's very important also to have a liquid core so we can have this magnetic field.
Yeah, so the core can actually be spinning around.
Yeah, exactly, because that's actually number one problem. Because if I come back to all the different things that are problematic, so as you said, Mars is further away from the sun, so it gets way less sunlight. So there are two different ways of warming up Mars. So either we create huge mirror and try to redirect the sunlight. It has
Cool.
been proposed. Some people
Oh, it
thought
was-
about this.
It was in the board game, I think.
Yes, yes,
Yeah.
exactly.
Yeah.
So there was also a science fiction book which was called the Red Mars by Kim Stanley
Yeah,
Robinson.
Red Mars, exactly.
Yeah, yeah.
That was the first of the Mars trilogy.
Yeah, they talk about this mirror ID. But in fact, if we really want that to be efficient, the mirror itself has to be bigger than Mars. Probably it might be a little bit difficult to do. Yeah.
Is there a way to drag a really shiny planet around and then
Yeah.
just point it at Mars? That way we don't have to
Yeah.
like build a mirror, like Enceladus, which has a lot of ice. We'll just use that.
Just reflect it onto
I like
the-
that.
I
onto the
think they were
poles.
thinking about just cover stuff with aluminized PET films and things like this.
Uh-huh.
It will be a little bit tricky. So maybe we can try the other option, which is increase the greenhouse gases, because obviously on Earth we're pretty good at that. So
Yeah, the cool thing about greenhouse gases for Mars is there is actually a whole stack of waiting there to be used. A couple of the things that we can probably use straight away on Mars is water, which is a really effective greenhouse gas. If you can get it in the atmosphere, it actually retains the heat for a planet quite well. And carbon dioxide, which there is a substantial amount of carbon dioxide in the atmosphere of Mars, but also locked up as dry ice on Mars. So the atmosphere of Mars is actually 95.3% carbon dioxide. The problem is the density and the thickness of the atmosphere is so low that it's not retaining much heat, and that's exactly why you're having these extreme temperature differences between day and night. So Sam, you mentioned that the day length on Mars is similar to Earth, but the temperature extremes are crazy between day and night. So they can swing by about 80 degrees or something like that. Does that sound
And
about right?
yeah, also you mentioned that the composition of the atmosphere is about, give or take 96% CO2. And that's pretty similar to Venus. This is about 95% CO2 as well.
Mm.
But yeah, it's just the pressure difference on Venus is
And the
so
total
different.
and total amount, the total abundance of
Yeah,
this
there's
as
so
well.
much more there.
Yeah, those two, like Mars and Venus, are great examples of extreme end members of the effects of greenhouse gas and how super important they are for like maintaining the temperature of a planet's surface. So yeah, Venus is hot all the time, everywhere on the surface. Mars is cold and hot depending on what time of day you're looking at, or even what season you're looking at. Whereas CO2 acts as like and greenhouse gases like water, methane, they act as like a planet blanket. They sort of retain and insulate the temperature. If you have too much, it stays too hot. If you have too little, then you have these extreme fluctuations. Earth is that Goldilocks zone, right, just right, not
Just
too
right.
much, not too little, and everything's pretty sweet for life here. So if we can get more CO2, more water in the atmosphere.
yeah, so apparently we could use this CO2 source, but it's probably actually not enough there anyway to create a thick enough atmosphere, because CO2 is probably not that powerful. So there has been people thinking about using other, for example, the CFC gases,
Yeah.
and that is better. It's a bit stronger.
Chlorofluorocarbons, and those were
Yeah.
they were banned from a whole bunch of aerosol
Yeah.
sprays in the 80s and 90s, wasn't it?
Yeah. So
And in refrigerators and a whole bunch of things. It was burning an ozone hole in the Earth's atmosphere.
Yeah.
yeah.
And so there was a book about that from James Lovelock and Michael Arabi, which is called The Greening of Mars. So yeah, they say that you could do that. But you said that earlier, that it really requires to actually bring millions of rockets there. And that would be pretty crazy, because they expect that you would have to send like 170 kilotons of it each year.
Alright.
Which is a bit much, right? So probably that's also probably not a very, very good idea. They were thinking that maybe they could also import hydrocarbons from Titan?
Yeah,
How to pronounce that?
Titan, yeah.
Titan. Which is one of Saturn's moon. but that is probably a bit tricky as well. Also, there is another thing that is extremely important is nitrogen,
Yeah, it's a big problem.
because nitrogen, if you think about it, it's very important gas on Earth, because all biological things like us would need nitrogen, tons of it, so we can make our protein and nucleic acids. It's also very important, like for example, let's say there is wildfires. Well, Mars is really cold, so it should be fine for a while, but if one day we start to make fires there, it's actually a bad thing, because adding nitrogen help to
sort of mitigate and keep fires lower
Yeah,
intensity.
exactly.
They don't burn as fast.
Yeah, and in fact, they figured that out a little bit tragically at NASA, because in 1967 there were three astronauts died on Apollo 1, because they kind of a bit underestimate the role of nitrogen and only use oxygen.
Yes, it was to do a test in the command module. And they completely filled the cabin with 100%
Oh yeah,
oxygen.
true.
And at that concentration of oxygen and no, like I said, no nitrogen, the whole thing becomes super flammable. So it's like a tiny little spark, and
Yeah,
all the internal cabin became, like even the metal became flammable, which is
yeah,
pretty intense.
yeah.
And so the
that
poor three
kind of-
guys carked it.
Yeah, so that really sucks.
Yeah.
So if we wanted to increase nitrogen, one thing that people have been thinking about, because it's kind of difficult, but some people were talking about bringing some asteroid, some nitrogen-rich asteroid, and make them collide.
Yeah, redirect an asteroid or
Yeah,
possibly a
yeah,
comet
because
or
of
something.
course we know how to do that. We're very good. Yeah. So they were thinking about sending that to Mars and then solving the nitrogen problem.
Yeah, because they found nitrogen's quite common in a lot of these chondrites, which is the most common types of asteroids we find, or meteorites.
And that's similar to another kind of way of possibly redirecting a comet to supply water, because they contain huge amounts of water as well. Yeah.
But yeah, the thing is that of course, like one of the problem is that then you also need to increase atmospheric density, because
that's super
and the
important.
gravity is very low and everything. So that's one thing that is important, because actually all our body liquids would actually boil. We really need a suit, because otherwise, like, we won't keep anything. So that's not cool. We will die like instantaneously. So that's one thing.
Yeah.
But if we want to increase this atmospheric pressure, we need the stuff to stay there and not the whole atmosphere to escape. And you were talking a little bit earlier about the fact that solar winds are a real problem, because it probably takes away most of the atmosphere that was there before. And we estimate that the atmosphere on Mars, that there was one that was kind of okay more than 4 billion years ago. But the problem is that, for example, they checked how some gas behave, like for example argon.
A noble gas, that one. That's
Yep.
noble.
So argon only escape by sputtering, like what happened when charged particles or ions are picked by solar winds, because they are charged, and they monitor argon, because unlike CO2, argon totally depends on those kind of things. Otherwise, it would just stay. But because of solar winds, it gets away, and they realized that actually 2/3 of argon was lost. So you can imagine that CO2 that can also escape by other processes likely decrease even more. So probably there was way more CO2 before, because there is no magnetic field, and that's the big problem. So we were talking before about melting frozen CO2 to increase greenhouse gases, but that's the problem. Like, we do that, stay there for a couple of days, and then it's all gone.
Is it that quickly though?
No, I'm
I was
kidding.
going to say, I mean, a lot of these projects are sort of, they do assume that these changes will be permanent, but that's not the case. I mean, like you said, it is a very temporary fix, and that is not the ideal situation if you have to keep replenishing it with new CFCs.
Yeah, exactly. So it's very difficult, and also there is no ozone, so that's the same problem, because it blocks the
Ultraviolet.
and that's very important, because otherwise it totally dissociate water molecules, so we can't keep water either, so that's a big problem.
I wonder what the problem would be if you introduce CFCs and ozone, because that was the whole point of the issue in the 80s and 90s. Is you had all these CFCs being released in the atmosphere, and it would react with the ozone, and then now we've got this giant ozone hole in the south hemisphere. So I wonder if that would be a pretty bad idea to mix those two. If you want to try and block out the UV, maybe don't try to pack in a whole bunch of CFCs in your atmosphere.
So that's actually the huge problem, because then we can try to do a lot of stuff, but main problem is the atmosphere. We need to make it denser, we need to make it real, we need to make it warm and comfy and everything, and this is so far not possible because there is no magnetic field. So one guy actually had this idea to build a planet-sized shield.
What?
Yeah.
Get out
At something that is called the L1 Lagrange point, which is actually
Lagrange point.
which is this point of neutral gravitational stability between the planet and the sun. And they were thinking about making this big shield, and that way then they can redirect the solar winds and prevent all this to happen.
So these are some pretty huge engineering projects.
Felt like a little project indeed.
Yeah, this is not the sort of project that you could, do into your primary school, like a potato battery or anything like that. This is planet changing, and you'd need an entire economy of the Earth to put in decades. So yeah, okay, not super practical yet.
Yep.
Think we need to try it out.
Yeah, I think we should just try it and see what happens.
Let's try.
I mean, what's the worst that could possibly happen?
What's the worst that can happen?
Mars.
Let's just fuck up the magnetic field in the solar system. Oh, that sounds so cool.
There's other planets we can try. Look, I like the fact that a whole bunch of people like the Mars Society and these other forward-thinking organizations are thinking about it, but none of the huge engineering projects we're talking about are going to happen probably within our lifetimes, unless we somehow live for 1,000 years or cryogenically freeze ourselves. A large part of it, these projects are going to be experimental though, and that's exactly the same problem we're having with geoengineering projects on Earth. Is if we're trying to change our atmosphere on Earth, we don't really know what the downstream effects are going to be. We might end up messing up a whole bunch of delicate ecosystem or delicately balanced atmospheric factors that we might not foresee until it's too late. I guess in some ways, testing these geoengineering or Mars engineering projects on Mars is a good way to test if they're going to work anyway, because they're not going to kill anything.
Well.
Uh-oh.
Well, who knows actually? Yeah, we only know very little about Mars anyway. We would actually kill the option if we screw it up. Like we can.
Yeah.
We only have one Mars.
Yeah, that's true.
We don't have 5 Mars. Like let's try 1 or 2 or something. It's probably better to try to make our ID before just tending nuclear bomb on it to try to restart the core. Or
Well, actually,
something,
the nuclear option was one that was put forward by Elon Musk and those folks. I think it was a couple of years ago. They were talking about how setting nukes off at the North Pole or at the poles to melt some of the ice locked up there would be a really good and quick and easy way, and using the technology that we have available today to start a thicker atmosphere, because you would cause the atmosphere to thicken by melting or sublimating the ice. The carbon dioxide would go in the atmosphere, the water would go in the atmosphere, you'd get some liquid water as well. You basically kickstart this terraforming approach with really dirty, quick and nasty, and if you're going to use nukes for anything, as Nelson Muntz once said, you got to nuke something. So you might as well nuke it for the planning of the future of humankind on another planet. Yeah, it's not a bad idea. But, of course, nukes in space is actually illegal. I don't know if you guys knew that. So,
Right.
yeah, you're not allowed to use nuclear weapons in space. And in the Cold War, there was this law put forward by joint partnership between the Soviet Union and the USA and the other nuclear powers at the time. And you're not allowed to set off nuclear weapons above, in the atmosphere or above it. So that might slow things down for a legal reason.
Yeah.
There's another pretty cool old idea by Carl Sagan. Again, he makes an appearance. 1973, he came up with this idea to ship, here we go, 10 to the power of 9, what is that, a billion? A billion to 10 to the power of 10, so it's 10 billion metric tons of low albedo material.
Oh yeah, I've seen that. Sorry,
Yeah.
I've seen that too.
Yeah, to Mars, which would rapidly bring the temperature
Yeah.
and the atmospheric conditions to Earth-like, or similar.
Yeah, because it lowers the albedo and just.
It warms it up.
And
Just
and
make-
I've seen that they were thinking about taking that dark dust from other stuff around.
Yeah. The ideal situation which Carl Sagan put forward was as a dark plant, which might be a good way to do it. If you have some sort
True.
of dark organism that's
Yeah,
actually photosynthesizing,
Mm.
it's bringing heat to the planet, and then the heat will melt some of the CO2 ice caps and the water so that things become more habitable. And then, because you've got a plant there, it's soaking up carbon dioxide and expelling oxygen. So you're trying to bring in multiple different favorable variables in one shot. And this is sort of what they call planetary engineering. You're basically trying to engineer an entire atmosphere, in this case, to make it more habitable. Okay, we're talking about tweaking the atmosphere to get it just right for life on Earth, particularly humans, if we want to stay there and colonize. But what would be the problem if we just had it not quite right? What if we had oxygen at 10% or 15% rather than 21% like we have it here? Or if we have the pressure slightly less than we have it on Earth? Are there any major problems with that? What are the tolerance ranges for humans? I guess that's a pretty important thing, because it might not be ideal, but it still might be livable.
Yeah, I think we're all going a bit crazy about the idea of living on Mars, and I think we really have to go a bit more in detail when we're watching on the astronauts which are in space at the moment on the ISS, for example. The life in space is actually really, really unhealthy. When you see that astronauts come back on Earth, then you probably have seen documentaries where they couldn't stay upright or walk because their muscles were weakened, and their bones lost a lot of density because they lost calcium. But usually they return to their old strength. But
This is because the gravity is so low, isn't that right?
Yeah.
The atmosphere can be fine, but if you don't have enough gravity to put your body under pressure or strain, then you're going to lose your bone density, you're going to waste away your muscles. It's pretty good.
Our bodies are highly adapted to the life on Earth and our gravity conditions.
Yeah.
It might not be so obvious, but it makes a huge impact, and not only on our muscles, also in a molecular way,
Ooh.
and also
Those are important.
and the life in space brings a lot of more trouble for our skin, our brain, our eyes, our immune system.
Yeah, I've heard
and
about the eyes as well. Yeah.
these are just some examples. We don't know about the rest. Yeah, we cannot imagine what happens when people stay in space for much longer.
Yeah, multiple years,
Multiple years, yeah.
Well, yeah, and you would stay in really low gravity for the whole trip to Mars. Not just that, but when you get to Mars, the gravity is substantially lower. What is it, like 38%? 38%, yeah. And we haven't really we haven't tested what effects that would have, but it's substantially lower than Earth.
But maybe we would be happy there. Yeah, okay, our bones will be less and everything.
So-
but we're on Mars, we don't need that much. And it would be so easy to walk around anyway, right? We will all feel like we lost weight and we're happy and
Exactly,
everything.
this is what they
Great.
think what happens. So our
Maybe
way
we adapt.
yeah, I think that will happen. So when we're going there to Mars, then it takes us 7 to 8 months, right?
Yeah.
So in this time, we're extremely weakened, especially our muscles and whatever, we don't know about it yet.
And the bones as well.
And the bones and some other points as well. And then we're going on Mars, and then we probably can walk a bit faster because the gravity isn't that high. Yeah, we probably would do great for an amount of time, but probably not forever. But what happens to other generations? People who are born on Mars. So they'll probably adapt to this environment, but they would have a lot of trouble to get back to Earth because they're not
Yeah, of course.
adapted to Earth.
Yeah, you're
They
right.
would be probably much more slender. They would not have so much muscles. But life there would be probably much tougher than on Earth here. Anyway, and I'm not sure if it's ethically correct to bring human to another
Well,
planet.
that depends. If you start to select them with weird criteria, yeah, probably ethically speaking, it would be a problem. Then if people volunteer,
Yeah, but if you're born there, you're actually not really a volunteer. You
You're a Martian.
have to
Oh,
live with that, probably.
That was a part of this plot line in this TV show at the moment. It's called The Expanse. Have you guys?
Ah, yeah.
Yeah. So
with this long people and
yes,
this racism
exactly. So
between the planets.
yeah, so they have different populations in different parts of the solar system. They have these Martians, and they also have these people living in the asteroid belt. And the spaces, or the ones in the asteroid belt, they have like very long limbs. Their bone density is quite low, but they're very tall, and they have real trouble going to Earth because the gravity is so much more extreme. So yeah, that's a cool little way to think that maybe humans will just adapt after multiple generations. There might be an initial phase of natural selection, as the people die because they're not, the genes aren't fit for it. But hey, look, if it's someone else you're sending, then go right ahead, I'm sure some people will say. So like you said, Miriam, that's a pretty unethical way to do it, because you're going to basically send these people off. And it's not so much the first generation that you feel bad for, it's the second generation. And if they can't adapt, then they're screwed. But they didn't choose to be there.
But isn't it what happened when they started to colonize Australia as well? Sorry.
That's true.
The second generation didn't choose to cook like
choose to be here.
much like poor English people. They were not fit. It took a while.
That's true. Yeah, that's true.
I don't know.
I think people want to go there. There are actually Kickstarter.
Yeah.
Yeah, the
But
Mars
maybe
One
at the
project.
beginning, and I think a lot of people wants to go as it's new because it's cool and new. But once we figure that, well, it's just same thing but a bit less cool and way more boring, then people will stop volunteering. So they better make kids over there. But
They're actually paying a lot of money to be the first Mars generation, right?
yeah,
It's a
I think
one-way
the first
ticket.
ones probably will get a lot of candidates. I'm just thinking afterwards,
Yeah.
like.
Oh, there are already people who are paying for that to be on the list.
Yeah, but I guess if they know they will be the first to go, then I guess it seems like it's cool. But then maybe
Yeah, I think actually the first generation will be really bored on Mars. To
yeah,
be honest,
I'm sure.
there's not so
sure.
much to do. I guess like the environment where you can stay is really limited, and even then, it could be suicide. It really could be suicide because
I thought that it was.
we really don't know what that makes to our bodies.
No, but I guess it is suicide anyway, isn't it? I mean, there is a lot of things that we are not sure. I mean, already if they manage to make it there, it's cool. Then if they manage to land, ooh, it's cool. Then if they already manage to terraform in it, well, that's cool. But then even once they're there, I mean, they need to not start a war and all this kind of thing. So I mean, there are a lot
I think
of
these are a lot steps.
yeah, there is a lot
Actually
of
get there.
steps in making it habitable.
But I think before we get to wars on Mars and between Earth and Mars, probably, who knows? I think the way to Mars is actually already a problem, and the first Mars expeditions will be a big problem for the people because they do a bit research about impacts that space makes to our body. For example, they found out that it makes actually a really big difference for our skin, and this was really surprising. So they measured the thickness of the skin, and after 6 months in space, it lost 20% of our skin thickness.
Ah.
Wow.
And what happens if they stay much longer there and much longer under lower gravity? And so researcher from the Saarland in Germany, they found that out, and they actually don't know the reason for that. It's probably the gravity, but they really don't know how to change that, and it's just one problem of many. For example,
God.
there's also the cosmic radiation, which makes a big impact to our brains. And they're doing a bit research with mice on the University of California, and they experimented with a high radiation of oxygen and titanium ions, and the results were that the mice had performance decrease, memory deficits, and loss of consciousness.
Ooh.
And
That's pretty important.
yeah, so we don't know what happens when we stay for a long, long time in space, or actually under high radiation, what would probably happen when we're living on Mars, because we don't have a magnetic field. We talked about that.
Oh yeah, exactly.
It's actually really cool that they can find out a lot of things that would improve our medicine in general. Astronauts on the ISS, they report as long as they stay in space, as worse becomes their sight. And after they return to Earth, it usually stays bad, and sometimes their visual nerves get inflamed also. So that's just after 6 months again.
And is this due to the low pressure or
no,
or gravity?
because I think they have the same pressure in the ISS. It's also because of the gravity, because the, how is it called,
cerebrospinal fluid.
Thank you very much. The amount of that fluid is bigger in the brain, because there's no direction probably where the liquids go. So this whole system is a bit out of
out of balance.
Out of kilter.
Yeah, exactly. So the pressure of their eyes is bigger, and they get flattened.
Flat eyes.
And that actually makes or brings the retina out of place. And
of course, and that way it won't be focusing on the retina anymore, because of the shape of your eye has changed.
Yeah, exactly. So it's irreversible bad afterward. And yeah, I'm not sure if you want that when you're going to Mars, because the gravity there is also lower, so they really don't know what to do about this.
They probably should learn this language, the
Braille.
Braille language first. Just to
Braille.
make sure, in case that happened, that they know how to follow instruction and everything.
Yeah, and there's not much to see on Mars anyway. I mean,
yeah.
Yeah. I wanted to mention that even the spine gets elongated, because of the intervertebral disc, they expand, and that makes a lot of dorsal pain. And so we need also a lot of painkillers on Mars. But people don't mind, they want to go there anyway. The immune system is also weakened of the astronauts from the ISS, and I think it's also a gravity effect, but they really don't know, because it's really molecular, and this immune response is interrupted by all the cells which had developed without gravity.
yeah.
Because some proteins don't work together anymore. Yeah, you cannot do anything about that at the moment. They found some really cool things which are helping now for autoimmune diseases, but they don't really know how to change that problem in space at the moment. So there are a lot of big problems to solve, and I think there are also a lot of big problems to find at the moment.
You're right. We're only scratching the surface. And whenever you read any assessment by a biologist, they're always very pessimistic about humans surviving in space or on Mars for any extended period of time.
Yeah, for a reason.
Whereas the engineers and the planetary scientists are, we can do it.
Let's do it.
Go for it.
But let's settle a hospital first. That's the first thing we do.
That's all you need. Just take drugs and get a hospital. It'll be fine. One of the ethical issues that we've just brushed on is not just the second generation of Martian colonists or terraformers. We can't do experiments on humans to see if this will work. We can do it on mice, and that may be okay. And even that's ethically dubious by some people. But if we wanted to actually breed humans under these conditions,
to be honest, we're doing experiments on our astronauts on the ISS.
That's
They're
true.
our
So
experiment.
That's true. But what I'd really like to know is whether, if you raise a baby from infancy into adulthood, will they adapt? Will their body and bone mass and density and muscle mass, will it just adapt to that conditions? And we don't have that data because of the ethical issues of raising a baby in space.
But we don't even know if it's possible to raise a baby in space at all. So.
Yeah.
One other ethical thing is, should we even bother? Should we try to change another planet to suit us, or is that just a bunch of chutzpah and unbelievable arrogance on our part to change a planet Should we just keep Mars as like a nature reserve that tourists can go visit? Or one of the really key things is if we actually find life there, should we mess with it, or should we just leave it alone and let it evolve for another 4 billion years? And hopefully, maybe we'll be able to talk to it when it evolves beyond the microbial form that it probably is, if we find anything. So, what do you guys think? Should we do this? Not whether we could do this, but should we do this?
It's a good question. Yeah, I think we definitely shouldn't. And I
Shouldn't?
think, yeah, I mean, we don't have to do it now. I mean, that's the reason why we have kids, right? So they can take care of the things we don't want to take care of, or we haven't figured out. Maybe we should try to leave a bit longer here, and that might be a good solution until our brain starts to figure things out, I would say.
On the pro terraforming side, people would say that we should do this. Just to give you a bit of background on why people are really promoting this, is because we have all our eggs in one basket. We have our entire species on one planet, and if we, I don't know, have a nuclear war and make the entire surface of the Earth uninhabitable, it's good to have like a backup plan, like a hard disk.
So
upload.
yeah,
I definitely think we should.
you were
Mars.
talking about the backup plan that would probably need like 10 times more than all the money that we can produce on Earth to make
It's
it.
a
I mean,
pretty
can you
elaborate plan.
imagine? We're talking about moving asteroid and try to collide them on Mars and try to make a new atmosphere and build a planet-size
Mirror or the
shield
shield.
and mirrors and stuff. Like, I mean. Yeah, sure, we can start now, but we can also just try to... Maybe evolution will make our brain bigger and better.
Yeah.
And maybe we should rely on that. And maybe we should just think about not making a war, a nuclear war. I don't know. But it's not just a small step. Like, if we are serious into that thing, that would just take all the money we have, all the energy we have, everything we have. We'll have to be focused on that. It's not just trying for fun.
Yeah.
I definitely think we should go for it. I mean, there's the backup.
Listen to this guy. As the backup plan.
Oh,
I
yeah.
mean, one of the main arguments is like, why not?
Yeah, why
What's-
not?
like,
Of course, but why
do
not?
it?
Economic?
Like,
Yeah, I would say
Money.
possibly, but
Yeah.
I mean, you don't really. It's pretty hard to foresee what it might generate in terms
Yeah,
of
that's
its
true.
economics and technology. I mean, the Apollo missions and going to the moon is probably the most inspirational
no,
thing
for sure.
that humans have
Yeah.
ever done.
Yeah.
And this would be like that,
Mhm.
but tenfold
Times,
possibly. So, I mean, the amount of science that it could generate itself, or the knock-on effects that it might generate, could be massive. And the actual end goal of creating another Earth-like planet is just, I mean,
No, it
the
sounds
most
cool,
incredible
right?
thing you
But
could
still,
imagine in a way.
but also trying to save the planet is also thankfully generating a lot of science and intelligence.
I think it
if
would-
can say.
It would make us think about how good Earth is, because
Yeah.
all these things that we're talking about and all these solutions to these problems, that they're already solved on Earth. Getting enough nitrogen in the atmosphere, getting enough oxygen. These things are just here, and we don't have to think about them. But these basic things are
We're
really
taking-
difficult to solve.
Yeah. We're taking them for granted, yeah.
Yeah. We kind of, when we go there, we can kind of look at how good Earth is in a way, and
Yeah, but
Just by how shit it is there.
okay, wait.
yeah.
Wait, let's say we manage to do it 10 years time, because like we have someone that is very rich and really clever and somehow solve all the problem, make Mars
Make Mars great again.
make Mars great again. Yeah, what happened on Earth? People feel like, who cares, I can go to Mars anyway, so it's not a problem. I don't actually need to care that much because we have this second home. Isn't it
Yeah.
where we go? Then
Possibly,
I don't
but,
know.
I mean, it might be like going to live in Antarctica or something.
Yeah.
Where it-
Well, Antarctica would be a
mean-
luxury compared to Mars.
exactly. I
Yeah.
mean, we can actually breathe in Antarctica, and we have the same gravity in Antarctica.
Yeah.
There's a lot of factors that make Antarctica, the most luxurious place to be compared to Mars. But I don't think we're ever going to get it. We're clearly not going to get it ever anywhere near as good as Earth for us. But yeah, I think that might be a key factor that makes people actually not think about, oh, screw this planet, we can move away, but it makes us actually appreciate our own planet even more.
Well, there were a lot of reports of people who went to space and came back and changed their view entirely. And in a really popular political speech recently, just to quote him, he said, "There's no planet B," and that's actually true. We cannot build another Earth. We just adapted to it, and we can try to make Mars as good as possible, but we will never reach our Earth. So I think we should start to improve our world with a bit more
gusto.
passion. Yeah, we should do a bit more about that, and I think it's a really interesting project. I think we should go for it, but I think it's really unlikely to create something where we actually can live. I think it's not possible, but it would be interesting for, I don't know, space vacations or something like that. I think that would change our view maybe, and
Space
probably
tourism.
every person on the Earth should do that, just to learn how important our Earth is and how important it is to take care about the Earth, about other species, and about our own species.
Absolutely.
Yeah. And going back to Carl Sagan, when he sort of persuaded, I think it was in the Voyager missions, to turn the camera around and take a photo of the Earth, and that's that famous pale blue dot photograph. And if we were to go to Mars, it's going to enhance these type of ways of thinking about looking at our planet as a whole and this tiny little dot that we're on. I think it will make us appreciate where we are more, and as well the fact that I think it's probably inevitable, if we are to go on long enough surviving as a species, that we will want to colonize other planets or other bodies in some way. The inevitability is sort of a reason to go for it in a way that we might as well try and think about it now and
Absolutely.
and sort of try to get it right first time, because
Even if we just spend the time looking and thinking about it and we find that it's too hard to do and we just have to postpone it because of practical reasons, I think there's something to be said for doing the science, seeing if it's going to work. Seems like if we're going to go down this path, Mars is the most likely candidate. But it seems like, from what I'm hearing from you guys, it's not going to be a one-stop fix because of the lack of gravity. So there's not active tectonics there, and we lose a lot of the atmosphere because of the lack of dynamo or the magnetic field. Have to constantly replenish it. And so the cost to maintain that planet may be ridiculously too high anyway. There's no push-button total recall solution to solving this problem. It was good to have you guys here this week. Thanks for all your input, and I hope to catch you all at the next tea party.
cheers.
Cheers. Bye.
This was the Cosmic Tea Party. Check us out on the internet at www.cosmicteaparty.org or send us an email, contact@cosmicteaparty.org. A big thank you to the very excellent Sanjeev Velu for our music.